time to have some fun. Everybody go wild. Let's go wild. Whoa, oh, oh. Let's go wild. Let's go wild. It's our day in the sun. It's our day in the sun.
We're under the sun, diving in. We learn to live on, try again. Forever alive, we live forever. We live forever. Now is your time, one more step. It's all or nothing, it's all or nothing. The last one left, my heart is pumping. Show me something, just watch me now. I feel the power, it's all that matters. I have no fear of what's next. Now is your time, the world is mine. Who are the heroes? Out of the shadows and into the light. Who are the heroes? I won't go down without a fight. From when we were young, diving in until we are gone. Try again. Forever alive, we live forever. We live forever. Now is your time, one more step. It's all or nothing, it's all or nothing. The last one left, my heart is pumping. Show me something, just watch me now. I feel the power, it's all that matters. I have no fear of what's next. Now is your time, the world is mine. Who are the heroes? time's been wasted, 'cause I know you've been working so hard. Just go, go, don't slow, keep chasing. It's time to show who you are. When it's late on your own, everyone's got hope. You know that I am with you. And when it's too hard, this game has gone too far. Baby, you know what to do. There's no giving up. Baby, you know what to do. There's no giving up. You know what to do. There's no giving up. Breathe in, breathe out, just keep moving. It's your moment to shine. No room for doubt, believe it. There's nowhere left to hide. When it's late on your own, everyone's got hope. You know that I am with you. And when it's too hard, this game has gone too far. Baby, you know what to do. There's no giving up. Baby, you know what to do. There's no giving up.
Ladies and gentlemen, please take your seats and silence your mobile devices. Our event is about to begin.
各位嘉宾，请您就座，主题演讲即将开始，并请您将您的手机调整为静音震动模式。
It's a long, hard road to follow. You pave the way. There'll be no more thoughts of tomorrow. One thing to say, there's no giving up. Baby, you know what to do. There's no giving up. You know what to do. It's a long, hard road to follow. You pave the way. There'll be no more thoughts of tomorrow. One thing to say, there's no giving up.
When the world is seeming kinda dark, you got that feeling in your heart. You think you might have lost the part back home. Just look into the sky and see the stars are there, they'll never leave. All you have to do is reach and you will feel a spark. Don't stop, you gotta keep on, 'cause you gotta have a little faith. Yeah, I know you got what it takes. What are you waiting for? It's time to have a little faith. Don't stop till you got nothing left. 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 Can you feel the energy? The world inside, you know I'm seized. Just open up and set it free tonight. Look into the sky and see the stars are there, they'll never leave. All you have to do is reach and you will feel the spark. Don't stop, you gotta keep on, 'cause you gotta have a little faith. Yeah, I know you got what it takes. What are you waiting for? It's time to have a little faith. Don't stop till you got nothing left. 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 Don't stop till you got nothing left.
I am a translator. Transforming text into creative discovery. Turning movement into animation. And infusing words with emotion.
台北是一个很棒的主办城市。
I am a healer. Exploring the building blocks that make us unique. Discovering new threats before they happen. And searching for the cures to keep them at bay. I am a visionary. Creating new medical miracles. And unlocking the secrets of our sun to keep us safer here on Earth. I am a navigator, finding a single moment in a sea of content.
We're announcing the next generation.
And the perfect setting for our most amazing stories. I am a creator, adding new dimensions to creative expression and reimagining our virtual selves. I am a helper, personalizing our surroundings.
Help me arrange the living room.
Harnessing the wisdom of a million programmers. And turning the real world into a virtual playground. I even helped write the script. Breathed life into the words and composed the melody. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Ladies and gentlemen, please welcome NVIDIA founder and CEO, Jensen Huang.
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
大家好 We're back. Our first live event in almost 4 years. I haven't given a public speech in 4 years. Wish me luck. I have a lot to tell you, very little time, so let's get going. Ray tracing, simulating the characteristics of light and materials, is the ultimate accelerated computing challenge. 6 years ago, we demonstrated for the very first time rendering this scene in less than few hours. After a decade of research, we were able to render this scene in seconds. 15 seconds on our highest end GPU 6 years ago. And then we invented NVIDIA RTX and combined 3 fundamental technologies: hardware-accelerated ray tracing, artificial intelligence processing on NVIDIA Tensor Core GPUs, and brand new algorithms. Let's take a look at the difference in just 5 years. Roll it. This is running on CUDA GPUs 6 years ago, rendering this beautiful image that would have otherwise taken a couple of hours on a CPU. So this was a giant breakthrough already. Enormous speed up running on accelerated computing. And then we invented the RTX GPU. Run it, please. The holy grail of computer graphics ray tracing is now possible in real time. This is the technology we have put into RTX, and this, after 5 years, is a very important time for us because for the very first time, we took our 3rd generation Ada architecture RTX GPUs and brought it to the mainstream with 2 new products that are now completely in production. Are you? Okay. Thank you. Thank you. Hey, I got it backwards. Can I have it this way? I got that backwards. Everything looks different, inside out and upside down. Okay, this is our brand new. Right here, you're looking at an Ada GPU running ray tracing and artificial intelligence at 60 frames a second. It's 14-inch. It weighs almost nothing. It's more powerful than the highest-end PlayStation. And this is the RTX 4060 Ti for our core gamers. Both of these are now in production. Our partners here in Taiwan are producing both of these products in very, very large productions, and I'm really excited about them. Thank you very much. I can almost put this in my pocket. AI made it possible for us to do that. Everything that you saw would have been utterly impossible without AI. For every single pixel we render, we use AI to predict 7 others. For every pixel we compute, AI predicted 7 others. The amount of energy we save, the amount of performance we get is incredible. Now, of course, I showed you the performance on those 2 GPUs, but it wouldn't have been possible if not for the supercomputer back at NVIDIA running all the time, training the model so that we can enhance applications. So the future is what I demonstrated to you just now. You can extrapolate almost everything that I'm going to talk about for the rest of the talk into that simple idea, that there will be a large computer writing software, developing and deploying software that is incredible, that can be deployed in devices all over the world. We used AI to render this scene. We're going to also use AI to bring it alive. Today we're announcing NVIDIA ACE Avatar Cloud Engine that is designed for animating, to bringing a digital avatar to life. It has several characteristics, several capabilities: speech recognition, text-to-speech, natural language understanding, basically a large language model, and using the sound that you will be generating with your voice, animate the face. And using the sound and the expression that you're saying, animate your gestures. All of this is completely trained by AI. We have a service that includes pre-trained models that you can come, developers can come and modify and enhance for your own application, for your own story, because every game has a different story. And then you can deploy it in the cloud or deploy it on your device. Has a great back end, has a TensorRT. TensorRT is NVIDIA's deep learning optimizing compiler, and you could deploy it on NVIDIA GPUs as well as output Onyx and industry standard backend so that you can run it on any device. Let's take a look at this scene in just a second, but let me first tell you about it. It is completely rendered with ray tracing. Notice the beautiful lights. So many different lights, and all of the different lights are projecting light from that source. So you have all kinds of direct lights. You have global illumination. You're going to see incredibly beautiful shadows and physics simulation. And notice the character, the beautiful rendering of the character. Everything is done in Unreal Engine 5. We partnered with a avatar framework, an avatar tool maker called COMPUTEX, and together we developed this demo you're about to see. Okay, run please. Everything is real time.
Hey Jen, how are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, Kai.
None of that conversation was scripted. We gave that AI, this Gen AI character, a backstory. His story about his ramen shop and the story of this game. And all you have to do is go up and talk to this character. And because this character has been infused with artificial intelligence and large language models, it can interact with you, understand your meaning, and interact with you in a really reasonable way. All of the facial animation completely done by the AI. We have made it possible for all kinds of characters to be generated. They're all domain, they have their own domain knowledge. You can customize it, so everybody's game's different. And look how wonderfully beautiful they are and natural they are. This is the future of video games. Not only will AI contribute to the rendering and the synthesis of the environment, AI will also animate the characters. AI will be a very big part of the future of video games. The most important computer of our generation is unquestionably the IBM System 360. This computer revolutionized several things. The first computer in history to introduce the concept of a central processing unit, the CPU, virtual memory, expandable I/O, multitasking, the ability to scale this computer for different applications across different computing ranges. And one of the most important contributions and one of its greatest insights is the importance of preserving software investment. The software ran across the entire range of computers, and it ran across multiple generations. So that the software you develop, IBM recognized the importance of software, recognized the importance of preserving your investment, and very importantly, recognized the importance of installed base. This computer revolutionized not only computing, and many of us grew up reading the manuals of this computer to understand how computer architecture worked, to even learn about DMA for the very first time. This computer not only revolutionized computing, it revolutionized the thinking of the computer industry. System 360 and the programming model of System 360 has largely retained until today. 60 years. In 60 years, $1 trillion worth of the world's data center all basically used the computing model that was innovated all the way 60 years ago until now. There are two fundamental transitions happening in the computer industry today. All of you are deep within it and you feel it. There are two fundamental trends. The first trend is because CPU scaling has ended. The ability to get 10 times more performance every 5 years has ended. The ability to get 10 times more performance every 5 years at the same cost is the reason why computers are so fast today. The ability to sustain 10 times more computing every 5 years without increase in power is the reason why the world's data center hasn't consumed so much more power on Earth. That trend has ended, and we need a new computing approach, and accelerated computing is the path forward. It happened at exactly the time when a new way of doing software was discovered, deep learning. These two events came together and is driving computing today. Accelerated computing and generative AI. This way of doing software, this way of doing computation, is a reinvention from the ground up, and it's not easy. Accelerated computing is a full stack problem. It's not as easy as general purpose computing. The CPU is a miracle. High-level programming languages, great compilers, almost anybody could write reasonably good programs because the CPU is so flexible. However, its ability to continue to scale and performance has ended, and we need a new approach. Accelerated computing is full stack. You have to re-engineer everything from the top down and from the bottom up, from the chip to the system software, new algorithms, and of course, optimizing the applications. The second is that it's a data center scale problem. And the reason why it's a data center scale problem is today, the data center is the computer. Unlike the past when your PC was a computer or the phone was a computer, today your data center is the computer. The application runs across the entire data center. And therefore, it's vital that you have to understand how to optimize the chips, the compute, the software across the NIC, the switch, all the way to the other end in a distributed computing way. And the third, accelerated computing is multi-domain. It's domain specific. The algorithms and the software stacks that you create for computational biology and the software stack you create for computational fluid dynamics are fundamentally different. Each one of these domains of science need their own stack, which is the reason why accelerated computing has taken us nearly 3 decades to accomplish. This entire stack has taken us nearly 3 decades. However, the performance is incredible, and I'll show you. After 3 decades, we realize now that we're at the tipping point. A new computing model is extremely hard to come by. And the reason for that is this. In order for there to be a new computing model, you need developers. But a developer would only come if developers have to create applications that end users would buy. And without end users, there would be no customers, no computer companies to build computers. Without computer companies like yourself building computers, there would be no install base. Without install base, there would be no developers. Without developers, there'll be no applications. This loop has been suffered by so many computing companies in the 40 years that I've been in this industry. This is really one of the first major times in history a new computing model has been developed and created. We now have 4 million developers, 3,000 plus applications, 40 million CUDA downloads in history, 25 million just last year. 40 million downloaded in history, 25 million just last year. 15,000 startup companies in the world built on NVIDIA today, building on NVIDIA today, and 40,000 large companies, enterprises around the world are using accelerated computing. We have now reached the tipping point of a new computing era. This new computing model is now enjoyed and embraced by just about every computer company and every cloud company in the world. There's a reason for that. It turns out that every single computing approach, its benefit in the final analysis is lower cost. The PC revolution that started and that Taiwan enjoyed in 1984, starting in 1984, the year I graduated, that decade in the 80s was the PC revolution. PC brought computing to a price point nobody's ever seen before. And then, of course, mobile devices was convenient, and it also saved enormous amounts of money. We aggregated and combined the camera, the music player, your PC, a phone, so many different devices were all integrated into one. And as a result, not only are you able to enjoy your life better, it also saves a lot of money and great convenience. Every single generation provided something new and saved money. Well, this is how accelerated computing works. This is accelerated computing used for large language models. For large language models, basically the core of generative AI. This example is a $10 million server, and we costed everything. We costed the processor, we costed all the chips, we costed all the network, we costed literally everything. And so $10 million gets you nearly 1,000 CPU servers, and to train, to process this large language model takes 11 gigawatt hours. 11 gigawatt hours. Okay, and this is what happens when you accelerate this workload with accelerated computing. And so with $10 million, for a $10 million server, you buy 48 GPU servers. It's the reason why people say that GPU servers are so expensive. Remember, people say GPU servers are so expensive. However, the GPU server is no longer the computer. The computer is the data center. Your goal is to build the most cost-effective data center, not build the most cost-effective server. Back in the old days when the computer was the server, that would be a reasonable thing to do. But today, the computer is the data center. And so what you want to do is you want to create the most effective data center with the best TCO. So for $10 million, you buy 48 GPU servers. It only consumes 3.2 gigawatt hours and 44 times the performance. Let me just show it to you one more time. This is before, and this is after, and this is we want dense computers, not big ones. We want dense computers, fast computers, not big ones. And so that's ISO budget. Let me show you something else. Okay, so this is $10 million again, 960 CPU servers. Now this time we're going to be ISO power. We're going to keep this number the same. We're going to keep this number the same. Okay? So this number is the same amount of power. This means your data center is power limited. In fact, most data centers today are power limited. And so with being power limited, using accelerated computing, you can get 150 times more performance with 3 times more cost. But why is that such a great deal? The reason for that is because it's very expensive and time consuming to find another data center. Almost everybody is power limited today. Almost everybody is scrambling to break new ground to get more data centers. And so if you are power limited, or if your customers are power limited, then what they can do is invest more into that data center, which has 11 gigawatts, and you can get a lot more throughput. Continue to drive your growth. Here's another example. This is my favorite. If your goal is to get the work done, you don't care how. Your goal is to get the work done, you don't care how. And this is the work you want to get done. ISO work. Okay? This is ISO work. All right, look at this. Oh, 先做嘴急。Taiwanese people love that, right? Nice to see you, Carol. Nice to see you, Spencer. Okay, so let's do that one more time. It's so delightful. Look at this. No. Okay, look at this. Look at this. Before, after. The more you buy, the more you save. That's right. The more you buy, the more you save. The more you buy, the more you save. That's NVIDIA. You don't have to understand the strategy. You don't have to understand the technology. The more you buy, the more you save. That's the only thing you have to understand. Data center. Now, why is it? You've heard me talk about this for so many years. In fact, every single time you saw me, I've been talking to you about accelerated computing. I've been talking about accelerated computing, well, for a long time, well over 2 decades. And now, why is it that finally it's the tipping point? Because the data center equation is very complicated. This equation is very complicated. This is the cost of building a data center. The data center TCO is a function of, and this is the part where everybody mess up. It's a function of the chips, of course, no question. It's a function of the systems, of course, no question. But it's also, because there's so many different use cases, it's a function of the diversity of systems that can be created. It is the reason why Taiwan is at the bedrock, at the foundation of the computer industry. Without Taiwan, why would there be so many different configurations of computers? Big, small, powerful, cheap, enterprise, hyperscale, supercomputing. So many different types of configurations. 1U, 2U, 4U, right? And all completely compatible. The ability for the hardware ecosystem of Taiwan to have created so many different versions that are software compatible, incredible. The throughput of the computer, of course, is very important. It depends on the chip, but it also depends, as you know, the algorithm, because without the algorithm libraries, accelerated computing does nothing. It just sits there. And so you need the algorithm software libraries. It's a data center scale problem, so networking matters. If networking matters, distributed computing is all about software. Again, system software matters. And before long, in order for you to present your system to your customers, you have to ultimately have a lot of applications that run on top of it. The software ecosystem matter. Well, the utilization of a data center is one of the most important criteria of its TCO. Just like a hotel. If the hotel is wonderful, but it's mostly empty, the cost is incredible. And so you need the utilization to be high. In order for the utilization to be high, you have to have many different applications. So the richness of the applications matter. Again, the algorithm and libraries, and now the software ecosystem. You purchase a computer, but these computers are incredibly hard to deploy. From the moment that you buy the computer to the time that you put that computer to work to start making money, that difference can be weeks, if you're very good at it, incredibly good at it. We can stand up a supercomputer in a matter of a couple of weeks because we build so many all around the world, hundreds around the world. But if you're not very good at it, it could take a year. That difference, depriving yourself the year of making money and the year of depreciation, incredible cost. Life cycle optimization. Because the data center is software defined, there are so many engineers that will continue to refine and continue to optimize the software stack. Because NVIDIA's software stack is architecturally compatible across all of our generations, across all of our GPUs. Every time we optimize something, it benefits everybody. Every time we optimize something, it benefits everybody. So life cycle optimization, and of course, finally, the energy that you use, power. But this equation is incredibly complicated. Well, because we have now addressed so many different domains of science, so many industries, and in data processing, in deep learning, classical machine learning, so many different ways for us to deploy software, from the cloud to enterprise to supercomputing to the edge, so many different configurations of GPUs, from our HGX versions to our Omniverse versions to our cloud GPU and graphics versions, so many different versions. Now, the utilization is incredibly high. The utilization of NVIDIA GPU is so high, almost every single cloud is overextended. Almost every single data center is overextended. There are so many different applications using it. So we have now reached the tipping point of accelerated computing. We have now reached the tipping point of generative AI. And I want to thank all of you for your support and all of your assistance and partnership in making this dream happen. Thank you. every single time we announced a new product, the demand for every single generation increased and increased and increased. And then, one generation, it hockey steps. We stick with it, we stick with it, we stick with it. Kepler, and then Volta, and then Pascal, and then Volta, and then Ampere. And now, this generation of accelerated computing, the demand is literally from every corner of the world. And we are so excited to be in full volume production of the H100. I want to thank all of you for your support. This is incredible. H100 is in full production, manufactured by companies all over Taiwan, used in clouds everywhere, enterprises everywhere. And let's take a look at a short video of how H100 is produced. It's incredible. This computer, 35,000 components on that system board, 8 Hopper GPUs. Let me show it to you. Whoosh. All right, this, I would lift this, but I still have the rest of the keynote I would like to give. This is 60 pounds, 65 pounds. It takes robots to lift it, of course, and it takes robots to insert it because the insertion pressure is so high and has to be so perfect. This computer is $200,000. And as you know, it replaces an entire room of other computers. So this, I know it's a very, very expensive computer. It's the world's single most expensive computer that you can say, the more you buy, the more you save. This is what a compute tray looks like. Even this is incredibly heavy. See that? So this is the brand new H100 with the world's first computer that has a transformer engine in it. The performance is utterly incredible. Hopper's in full production. We've been driving computing, this new form of computing, for 12 years. When we first met the deep learning researchers, we were fortunate to realize that not only was deep learning going to be a fantastic algorithm for many applications, initially computer vision and speech, but it would also be a whole new way of doing software. This fundamental new way of doing software that can use data to develop, to train a universal function approximator of incredible dimensionality. It can basically predict almost anything that you have data for, so long as the data has structure that it can learn from. And so we realized the importance of this new method of developing software, and that it has the potential of completely reinventing computing. And we were right. 12 years later, we have reinvented literally everything. We reinvented, of course, we started by creating a new type of library. It's essentially like a sequel, except for deep learning, for neural network processing. It's like a rendering engine, a solver for neural network processing called cuDNN. We reinvented the GPU. People thought that GPUs would just be GPUs. They were completely wrong. We dedicated ourselves to reinventing the GPU so that it's incredibly good at tensor processing. We created a new type of packaging called SXM and worked with TSMC on CoWoS so that we could stack multiple chips on the same die. NVLink so that we can connect these SXM modules together with high-speed chip-to-chip interconnect. Almost a decade ago, we built the world's first chip-to-chip SerDes so that we can expand the memory size of GPUs using SXMs and NVLink. And we created a new type of motherboard we call it HGX that I just showed you. No computers has ever been this heavy before or consumed this much current. Every aspect of a data center had to be reinvented. We also invented a new type of computer appliance so that we could develop software on it, so that third-party developers could develop software on it, with a simple appliance we call DGX. Basically, a giant GPU computer, DGX. We also purchased Mellanox, which is one of the great strategic decisions of our company, because we realized that in the future, if the data center is the computer, then the networking is the nervous system. If the data center is the computer, then the networking defines the data center. That was an incredibly good acquisition. And since then, we've done so many things together, and I'm going to show you some really, really amazing work today. And then, of course, an operating system, if you have a nervous system, a distributed computer, it needs to have an operating system. And the operating system of this distributed computing we call Magnum I/O, some of our most important work. And then all of the algorithms and engines that sit on top of these computers, we call NVIDIA AI. The only AI operating system in the world that takes data processing, from data processing to training, to optimization, to deployment and inference. End-to-end deep learning processing. It is the engine of AI today. Well, every single generation since Kepler, which is K80, to Pascal, Volta, Ampere, Hopper, every 2 years, we took a giant leap forward. But we realized we needed more than even that, and which is the reason why we connected GPUs to other GPUs called NVLink, build one giant GPU, and we connected those GPUs together using InfiniBand into larger scale computers. That ability for us to drive the processor and extend the scale of computing made it possible for the AI research organization, the community, to advance AI at an incredible rate. We just kept pushing and pushing and pushing. Hopper went into production August of last year. August 2022. 2024, which is next year, we'll have Hopper next. Last year, we had Quantum. 2 years from now, or next year, we'll have Quantum next. So every 2 years, we take giant leaps forward, and I'm expecting the next leap to be giant as well. This is the new computer industry. Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers. These AI supercomputers are a new type of factory. It is very logical that a car industry has factories. They build things that you can see, cars. It is very logical that computer industry has computer factories. You build things that you can see, computers. In the future, every single major company will also have AI factories. And you will build and produce your company's intelligence. And it's a very sensible thing. We cultivate and develop and nourish our employees and continue to create the conditions by which they can do their best work. We are intelligence producers already. It's just that the intelligence producers, the intelligence are people. In the future, we will be intelligence producers, artificial intelligence producers. And every single company will have factories, and the factories will be built this way. This translates to your throughput. This translates to your scale, and you will build it in a way that is very, very good TCO. Well, our dedication to pursuing this path and relentlessly increasing the performance. Just think, in 10 years' time, we increased the throughput, we increased the scale, the overall throughput across all of that stack by 1 million x. 1 million x in 10 years. Well, just now, in the beginning, I showed you computer graphics. In 5 years, we improved the computer graphics by 1,000 times. In 5 years, using artificial intelligence and accelerated computing. Using accelerated computing and artificial intelligence. We accelerated computer graphics by 1,000 times in 5 years. Moore's law is probably currently running at about 2 times. 1,000 times in 5 years. 1,000 times in 5 years is 1 million times in 10. We're doing the same thing in artificial intelligence. Now, question is, what can you do when your computer is 1 million times faster? What would you do if your computer was 1 million times faster? Well, it turns out that the friends we met at University of Toronto, Alex Krzyzewski and Sutskever and Ilya Sutskever and Jeff Hinton, Ilya Sutskever, of course, was the founder of OpenAI, and he discovered the continuous scaling of artificial intelligence and deep learning networks and came up with the ChatGPT breakthrough. Well, in its general form, this is what has happened. The transformer engine, and the ability to use unsupervised learning, be able to learn from a giant amount of data and recognize patterns and relationships across a large sequence. And using transformers to predict the